All right, moving on to the sort of the last item that we'll do today. Rick Pector is going to give us a presentation that he's been working on about answering that core question that we often get from our customers: why use MicroStrategy for data science? Rick probably doesn't need much of an introduction to most of you folks. He was in the technology group for almost 20 years and is responsible for most of the features that are in the product at present. So over to you, Rick.
Hey, thanks, Derek, and good morning or good afternoon, everybody. And it's not surprising where I get involved in a presentation and I'm speaking to non-MicroStrategy users, especially data scientists, typically may not even know what MicroStrategy is or that we exist in their organization. And so this presentation I'm showing you here is my strongest positioning of MicroStrategy as a data science tool. And so imagine you're presenting to a MicroStrategy customer and you maybe have a data science team in front of you. I'd like to include this slide at the beginning because some people may not be familiar with MicroStrategy, and so I'll talk about how MicroStrategy is a modern analytics platform that sits on top of your data sources and turns all that information into actionable insights delivered to users on the front lines throughout the organizations in their preferred touch points, like desktop and web and mobile. And that is the name of the game here, is delivering information out to users. And let's face it, if the data science results do not need to be delivered beyond the team that develops them, then you don't need MicroStrategy in the loop. On the other hand, when you do need to put data science results into the hands of users throughout the organization, MicroStrategy is the #1 platform for doing that, and this presentation hopefully will show you why. At the highest level, you should think of MicroStrategy as a centralized platform that delivers trusted data from hundreds of data sources. Today we'll show you how MicroStrategy's open architecture was built from the ground up with analytical extensibility in mind, which means that MicroStrategy streamlines the adoption of the latest machine learning technologies and puts advanced analytics in the hands of users on the front line and everywhere throughout the organization using simple, easy-to-use tools delivered seamlessly to the touch points that they use. What I plan to cover today is 4 reasons why MicroStrategy for data science. First, I'm going to tap into the most recent Gartner critical capabilities evaluation that took place just last month. I'm going to talk about the MicroStrategy semantic graph, formerly known as metadata. I'll talk about how data scientists can bring their own tools, and as well as hopefully throughout the presentation we'll be incorporating use cases that show you how we can frictionlessly deploy data science results out to users. First, I want to focus on the Gartner critical capabilities report. This was just released last May, and MicroStrategy received the highest aggregate score of all the vendors, including being the leader amongst all the leaders for 12 out of the 15 different capabilities evaluated. So let's briefly explore these results and what they mean for data science and data scientists. Now, I'll warn you up front, I'm a big fan of maximum information density, and this slide is definitely a busy one. The table has summaries Gartner created from their results, where we have a row for each of the nearly 24 vendors that Gartner evaluated, and 15 columns with the critical capability results, plus totals for each vendor on the right. Now, this table is sorted in descending order, and MicroStrategy is at the top, because MicroStrategy was the only vendor with a score in the 60s out of a possible score of 75. I'd like to focus your attention on the critical capability that Gartner has established for advanced analytics. Gartner defines this as enabling users to easily access advanced analytics capabilities that are self-contained within the platform itself or through the import and integration of externally developed models. I couldn't have written that better if I wanted to describe what MicroStrategy can deliver in the space of data science in the BI arena. While TIBCO got a bit of a nod in top scores here, MicroStrategy is just a step behind, and we're tied with SAS, which I found very rewarding. Not too shabby, especially since MicroStrategy does not compete in the data science market against the likes of SAS or IBM SPSS or SAP KXCN. Finally, I just have to point out there's a lot of mergers and acquisition activity going on in this space. Just in the last few weeks, Tableau was acquired by Salesforce for nearly $16 billion. Google acquired Looker for over $2.5 billion. Logi Analytics has acquired Zoom Data, trying to improve their position. And this kind of reminds me of a lot of the mergers and acquisitions activity that we've had in the market in the past. including IBM's acquisition of Cognos and later SPSS, as well as SAP's acquisition of Business Objects and later KXCN. Years later, it's fair to say that the acquired companies' technologies have kind of all but disappeared from the marketplace after being consumed into their conglomerate parent. MicroStrategy, on the other hand, was organically built over the past 3 decades and continues to outperform these competitors, and in particular, those competitors who try to compete through acquisitions instead of the organic innovations that MicroStrategy has been adding to the platform over the years. And we're going to touch on a few of those as we go through the presentation today. In this critical capability survey, Gartner further, boiled down those 15 capabilities into 6 key use cases. And as you can see on the screen here, MicroStrategy was number 1 in 4 out of the 6 and number 2 in the 5th one. In addition to being ranked number 1 for extranet deployment and number 2 for decentralized BI provisioning, MicroStrategy was ranked number 1 for agile centralized BI provisioning, plus number 1 for OEM or embedded BI. And finally, what I want to focus on is how MicroStrategy was voted number 1 for governed data discovery. In fact, the reason why this is important is that it allows MicroStrategy users to be self-serving, yet have a single version of the truth that they can operate on. And that's probably one of the biggest criticisms of some of the other data discovery tools out there in the market today, is that they just don't scale past the department level. And when it comes to enterprise analytics, you really want to make sure that, independent of what department or organization or part of the business you're operating from, the data that you have can be trusted. And that's where MicroStrategy really shines in the governed data discovery market, and why that's so important for data science is something we'll focus on in the rest of the presentation today. Let's talk about users. And I'd like to think that there are 3 types of analysts in an organization. First, there's the business intelligence analysts. They're in search of answers, and they can be found anywhere, everywhere in the organization. These users are searching for answers so they can do their job better, and their tools have to be simple and easy to use, requirements that MicroStrategy is the industry leader in meeting. Moving up in the analytical maturity is the citizen data scientists. Typically, these are BI analysts without specific training in statistics or data science who are looking for an edge. They often are found on the front lines, and their ego is based on being innovative and their ability to take data to new levels. They'll use any tool if it's the right tool, and today there are more options than ever before, the most popular being R and Python for doing data science, and we'll talk a little bit more about that today. Finally, we have our data scientists, analysts who have special training in statistics and advanced analytical methods. Well, this is not meant to be derogatory. They're often found embedded in specific teams, often kind of called in the back office versus the front lines, like marketing or operations or finance. Their ego is based on the ability to rigorously apply the best analytics for the job and to accurately quantify correlations and confidences when estimating past and future performance. They need their favorite tools in order to do their job right, and here are some of the logos of the wide variety of tools out there today. So in order to understand why MicroStrategy for data scientists, let's focus on what data scientists do. Well, there's lots of different types of analytics. This workflow is applicable to virtually all data science efforts, which ideally should start with a clearly defined goal that describes in business terms the problem to be solved. With that goal in mind, all analytics developed by a data scientist follow a process that at a high level covers how the data is sourced, where the algorithms are run that will build analytical models, where the algorithms are run that will apply the models to data, and how those results are deployed to end users. Now, while this chart shows every step in the process is roughly the same size, that can be very misleading. Let's see what data scientists spend the most time doing. I want to give credit to Jeff Maddox. He came up with this survey, and I love it as a hook to talk about how data scientists spend their time. Let's compare the steps to the results from this recent survey that data scientists who are asked what do they spend most of their time doing. In fact, let's make this a little bit of a quiz. Here are 4 different options, only one of which represents the results of this survey. What's your guess? Do data scientists spend the most time mining data, which is option A, building data sets, option B, data modeling and cleaning, option C, or model refining, option D?
Data modeling and cleaning.
Excellent choice. That's right. The answer is C. And according to this survey, data scientists spend most of their time data modeling and cleaning, with data collection a distant second. Most surprising to me is how the activities I would expect data scientists to do only had single-digit % results. Why might this be, and how can MicroStrategy help data scientists spend more time doing data science? Well, let's break down each of these areas. First, there's data collection. These days, there's the number and variety of data sources is constantly evolving beyond the traditional SQL sources from the past to new solutions like multidimensional expressions or MDX, big data sources like those leveraging Hadoop and NoSQL tools, plus the ever-increasing universe of enterprise applications that are rich with data. And of course, let's not forget all those spreadsheets, flat files, text files, and access databases that are still in use across organizations today. Because all their jobs depend on data, data scientists are usually quite adept at pulling together data from disparate sources, and that's where they spend the lion's share of their time, transforming all that data into one big flat table, the format required by virtually all data science tools. The final step is delivering those results, also known as scores, out to end users. Now, MicroStrategy should be able to help reduce the time spent on those upfront activities, and let's see how MicroStrategy can improve this process so data scientists can spend more time doing data science. Data science needs a solid foundation to unlock data, and it's fair to say that most enterprises have their data locked up in tables and columns found in relational databases that are queried using the structured query language or SQL. Relational databases store data by normalizing it into fact and lookup tables in order to reduce data redundancies. Because of that, they're typically optimized for storage efficiency and not necessarily performance, although database techniques like indices and aggregate tables can improve response time for many queries, and MicroStrategy supports those. That's why for decades, MicroStrategy's SQL engine has been the best in the industry at turning users' requests into SQL queries that return results from these normalized relational data sources. At the other end of the normalization spectrum are multidimensional databases. These structure data into cubes that are composed of dimensions and levels and elements and measures, and are queried using multidimensional expressions or the MDX language. In addition to being more intuitive for users, MDX sources are optimized for performance, but they have a downside of suffering from cube explosion, which inherently limits the amount of data they can store, especially as the size and hierarchical complexity of these cubes grow. Both SQL and MDX sources structure data as it's being stored, sometimes called schema on write. But today there are newer approaches that have gained commercial success just in the past decade. Big data technologies like Hadoop famously do not attempt to structure data on the way in, and instead leave it for the user by employing a schema on read approach that structures that data on the way out. NoSQL technologies are often queried using document object model structures like JSON, which is similar to XML but less verbose. Finally, there are applications, which not surprisingly are queried using application program interfaces or APIs, including the common RESTful API, which is supported by many applications. At the other end of the spectrum, no matter how the data is stored, most data science applications simply need data in one big flat table with a record or observation per row and descriptive variables on columns. Now, while this is just a sliver of time spent according to the data scientists in our survey, I kind of feel that it's only that big fat table has gone through many iterations by the time they're ready to use this data in a data science tool. It's this conversion from how data is stored in each of the data sources to this big flat table format is where data scientists spend the vast majority of their time. Fortunately, all data science tools have features to facilitate this process, including popular packages that are available both for Python and for R. Ultimately, the structure of these data sets depend on the nature of the problem being solved, which is why the goal up front is so important And remembering it is also important since that goal ultimately depends on building the right data set for the problem at hand and ensuring those data definitions will be consistent when the resulting models are deployed to end users. And so that's what we want to do. We want to see about how we can take these data sets and deliver them from the sources that we have. That's really what I will call data science challenge number one, building that big flat table data sets from diverse governed sources that analytical models require while ensuring that all users experience a single version of the truth. To do this, let's explore how MicroStrategy's approach to governed data discovery helps you make sense of all this data. Now, data is hierarchical by nature, and most users are comfortable of thinking of their data in terms of dimensions and hierarchies. For example, a model for a retailer might help answer questions like, what products were sold, which geography did the sale take place, which customer brought the product. These dimensions are all attributes of a retail transactions. They describe what was sold, where it was sold, who it was sold to. Each of these dimensions can describe a unique set of attributes. The product dimension is composed of items, and each item can be grouped into subcategories and categories. For example, a quart of milk is an item that would logically be a member of the dairy subcategory of the grocery category. The geography dimension might start with the employee who performed the transaction in the store they work in, and each store might be grouped into regions of the country where the sale was made. Similarly, customers can be grouped into cities and states and regions and countries as well. But a customer is not a customer without an order that represents the sale, and that's probably the most logical entry point into this hierarchy for customers. And all these hierarchies are not complete without incorporating all the other attributes in the data that further describe each product, each geography, and each customer. But there's still a couple other important concepts that are missing. Virtually all applications involve one or more time dimensions, which can also be thought of as a hierarchy of different attributes. And all these attributes cry out for facts that measure things that it tells us like things like how many items were sold, how much did they cost, how much profit was made. The good news is MicroStrategy users interface and interact with these measures using an object we call metrics. And when you combine all these attributes and metrics together, it's easy to see how multidimensional our data can be. It's natural, even logical, to think of data as a multidimensional cube. Logical schemas like this make it easy to ask questions and are a natural way for humans to query. But you cannot cube the universe, especially in this area of big data that we're in. MicroStrategy always prefers to leave data in place because that's how you ensure a single version of the truth. Which is why I prefer to think of MicroStrategy's cubes as caches. A MicroStrategy cube is an in-memory cache of application-specific data, domains of information with locality of reference that are likely fast, while being backed by high-performance access to governed data sources. But while data is multidimensional, data scientists prefer two-dimensional data sets. And so we can think of the data science data sets as simply a two-dimensional slice of this multidimensional universe and allows the data scientist to pull together the right data set for the type of problem that's being solved. And so by hiding the intricacies of data access from the user, MicroStrategy helps quite a bit with this challenge of turning all those data sources into big flat tables so you can perform some data science. And that leads us to our second challenge of how do we deploy those data science results to users on the front line in simple, easy-to-use tools. Well, not surprisingly, there's a common answer and solution to both of these problems, and that's MicroStrategy's platform. What you don't need is another tool. What you do need is a platform. And this is MicroStrategy's Map of the Intelligent Enterprise. It's another maximum information density product that we produce. It's really a wall chart that shows organizations how to convert different data sources at the bottom and turn all that information out to users at the top. And in between, what we have is the MicroStrategy platform. What's the cool thing about this is MicroStrategy users don't have to worry about what table or column or cube or NoSQL source that they're accessing. They deal with our metadata and the objects there that define data in terms of business rules that they're used to dealing with. And so MicroStrategy just came out with version 3 of our Map of the Intelligent Enterprise, and we've kind of recoined what historically has been known as metadata as our semantic graph. And if you'll bear with me for just a few minutes here, let me break through what exactly goes on with the MicroStrategy semantic graph. This has been evolving since MicroStrategy was founded in 1989, and at the beginning, we always started with this semantic layer. The lowest elements, the atoms, if you will, of MicroStrategy's universe are attributes and facts. And as we saw in the earlier slides, we need attributes to describe information, and we need facts that help us measure things. Now, these schema objects have a few other partners that help do things. We need functions that tell us how to group or organize or combine the fact data in our data sources to higher levels of aggregation, or to ensure that we're delivering the right calculation to the right definition at the right time. Now, as I've shown you before, these attributes can be grouped into hierarchies. And in fact, we have another type of schema object called a transformation that's useful in doing things like year-to-date and year-over-year and other time transformations like that. And in the MicroStrategy universe of objects, this semantic layer surprisingly just has a handful of elements. And this foundation of schema objects is going to form the basis of building applications out in the future. And so back in starting in 1989, in the first decade of MicroStrategy, we had about 300 functions that were available out of the box in the platform that allowed us to do these conversions of source data into definitions that can be used in MicroStrategy applications. And this is where we get into the application layer objects. And this is an ecosystem of reusable application objects that allow you to build applications that are able to be able to reuse these objects over and over again and have consistency, so new projects can leverage and build on the work that was done in the past. Let me show you how that can work. My favorite application object is the metric, and metrics are really powerful entities in the MicroStrategy universe. I've kind of made my whole career doing amazing things with metrics and functions. A metric is simply just a combination of a fact and an attribute. Once we know how to take that data and aggregate it, we're able to do a calculation. We can then combine metrics onto a template, and we can add a filter and combine those together. If you've learned anything in MicroStrategy, you may have learned that a report is simply a template with a filter. And so with that, we're able to then also do fancy things like filters can be part of another filter. Metrics can be used to build other metrics. We can even use reports as filters. And so this is a pretty powerful description of what our environment can do as well, including other things like subtotals and prompts. And the first 10 years of the company was spent building out this application layer of objects that allows users to build things with. Now, I do have some examples that I can go through and showing how we can do various things, including things like a trend analysis. These are all little 1-minute videos that I'll click on here. For example, if I want to understand the average length of stay for my organization, I'm going to use MicroStrategy's natural language query capability to show the average length of stay for an organization for the last 5 weeks. I'm able to put this on a dossier. I'm able to add some reference lines. I can see that my average length of stay varies from about 6, going to a minimum of 4 to a maximum of 8. I can do some trend lining and see what the general trend of this data. It seems to be pretty flat. I can do things like changing the curve fit to try and look and see how best I can describe this, including R-squared values that explain how much variability is explained by that line. I can even understand seasonality with our trend lines, and I can see here that even our best trend line explains just about half of the variability that's going on with this data. I can also use our trend lines to forecast ahead in the future, and notice that this trend line does pick up on the cyclical nature of our data. So that was pretty cool. Let me jump into another video here that shows how I may want to see if there's a correlation between flu season and our average length of stay. Imagine an organization puts out sanitizers on a very rigid November through April flu season. Well, we can see, that flu season seems to be correlated with our average length of stay, but I can use our natural language query to just simply ask, tell me how flu season varies by average length of stay. And I can see that, yes, flu season is longer during, or average length of stay is longer during flu season. We can actually show you the numerical correlation between average length of stay and flu season. But can we do better? That rigid definition of flu season doesn't seem to capture everything with average length of stay. I'm going to go and look at Google Trends here. I'm going to go and look at the search term for flu, I'm going to go and download the last 5 years of Google Trends for flu. I'm going to copy that data. I'm going to add it to my dossier. And so I'll go ahead and place this data that I've just simply copied in my clipboard. I'm going to do a little bit of data prep. I'm going to rename my target Google Flu, so I know this was the results from my Google search. And then I'm going to, after I join the date dimension here, I'm going to add that to my dossier. And now I'll do another natural language query to show me the correlation between Google Flu and flu season. And what I find is that I actually have a better correlation using the Google Trends versus my rigid definition of flu season of just saying it's November through April. And so that's an interesting way, and I was able to show you how you can do some data science stuff like correlation. One more video here that kind of shows how to do pairwise correlation using our integration with R. I'm actually going to build a data set here that builds 3 columns of my average length of stay, my flu season, and my Google Flu results. And I'm going to now create another metric that's going to allow me to compare those 3 variables together and take them 2 at a time to do pairwise correlations. I'm going to go over to our R script shelf and grab an off-the-shelf R script that has the definition for how I can do this pairwise variable correlation. I'm going to customize this metric expression a little bit so it focuses on the 3 variables that I'm trying to compare here. And I received an OK in those columns there, so I know my plot worked. I'm actually able to go and grab my pairwise variable correlation plot, and notice that 39 matches my discrete correlations that I had before, and the 52% also matches. And so what we've done here is actually shown you a few ways to do correlations with MicroStrategy. Let me jump back to my semantic graph and jump into the next decade of MicroStrategy, where we added some more capabilities such as documents. We also added some things like custom groups and consolidations. The MicroStrategy's second decade was also when we introduced some of our native predictive capabilities. And MicroStrategy supports the PML standard and allows us to import models as well as persist models in MicroStrategy metadata using the XML language PML, probably the lingua franca of predictive model interoperability between tools that support the standard, including SAS, IBM SPSS, SAP KXCN, and MicroStrategy for representing predictive models. And so there's a few more demos that I have and examples of this. I know I'm running late, and we're running up at the top of the hour for the call today. So I'll leave these for a little bit to show some things. One thing I'll jump into maybe is this last dossier here to show how we can add existing predictive models and scores to my dossier from a different data set. I'm going to join in here my actually predictive data set that I use to do forecasting ahead in the future for using MicroStrategy native predictive algorithms. And I'm able to go ahead and add these forecasts and their residuals, the amount left over, and I can begin to compute how well my model did on actual results. And your predictive model, you really don't know how well it performs until you test it against some actual results. In this case, we trained a model on data up until 2019, holding 2019 as the future. And in this case, we built a couple different models, a regression and a time series natively with MicroStrategy, and it had mean percent errors in the low teens, which wasn't too shabby. In our next decade, the most recent decade that we've done, MicroStrategy continued to evolve our metadata and even committed to add even more capabilities. This decade brought the concept of cube to fore. We've already talked about that. You've also seen MicroStrategy dossiers at work. This is also the time that we also released our integration with R. I'm a big fan of our R integration just because R has over now 10,000 packages and millions of practitioners. And plus MicroStrategy has one of the tightest integrations with R in the industry because we can execute R natively within our engine. And so when we talk about our capabilities, I showed you an R integration just before with our pairwise correlation. This decade also saw the introduction of a lot of other capabilities, such as certifications and synonyms. We had identity and hypercards appear. A lot more capabilities have shown up recently. Most excitedly from a data science point of view is the addition of our Mysterio packages that we've released in support of R and Python, which allows users and data science teams to access data in MicroStrategy and use MicroStrategy as a data source, as well as return scores to MicroStrategy so they can be delivered to users. And I want to focus a little bit on Mysterio here. The cool thing about it is whether you're a Python user or an R user, it's very simple to install the MicroStrategy Mysterio package, and with just a simple one-line execution, you can install it and you're good to go. Mysterio does just a handful of things that you would need to do to access data in MicroStrategy. You can connect to a MicroStrategy project securely. You can download a cube or a data set, also known as a data set, or a report. You can upload a cube or report to MicroStrategy. There's also a fourth command that closes the connection, not shown here. And so the very cool thing about Mysterio is it allows you to access the entire environment from a data science world and bring all the power of MicroStrategy metadata and our semantic graph to the data science community. Now, when we talk about data scientists, there are a number of different tools that are available, and I have the 2018 Katie Nuggets Data Science Survey that had a number of participants, a number of data science users worldwide participate in the survey. One thing that was interesting about this survey is on average, participants use 7 different data science tools. You'll notice Excel is on the list here, as well as some other things. What's interesting is the guys at Katie Nuggets found that RapidMiner probably stuffed the bad box on this, and so I want to pull them out of this. What we can see is that while R had a slight lead over Python back in 2016, Python seemed to pass, at least in this survey, popularity from R in 2017. And in 2018, Python is clearly has a lot more data scientists using Python versus R for data science. That's probably just a factor of more students learn Python in school. It's more of a software engineering language where R was built for statisticians by statisticians, and so it has a bit of a steeper learning curve. What's also interesting here is that while MicroStrategy supports connectors and has a great integration with R, both R and Python are well supported. MicroStrategy obviously has a SQL engine. We also have connectors for Excel. We've also released a connector with our federated analytics for Tableau. I've worked with Anaconda, which on my PC allows me to run Python under the covers. Technology like Anaconda allows us to get access to things like scikit-learn and TensorFlow. One of the coolest things I like is the package Keras, which 2 years ago didn't even make this survey, but now has about a quarter of the respondents saying that they use. Keras is an open source language for building deep learning models, and it's something that MicroStrategy actually has used as for in development new off-the-shelf R script for deep learning. And so let's go back to our data science workflow and lay these steps out again. Again, we're trying to deliver results to MicroStrategy users. The MicroStrategy citizen data scientist, well, they would simply get governed data from MicroStrategy. They could use MicroStrategy's native capabilities, or they could use Python and R to go ahead and deliver results out to end users. But for the data scientists, they have a slightly different approach. Data scientists are very good at getting at data, and that's the name of the game. And so they're going to typically pull data from a number of different sources. Data scientists will then use a data science, either their R console or their Jupyter platform or a data science server to do their data science work. MicroStrategy supports a number of different tools as well in this area for doing data science. In fact, most data scientists will stop at this point. Once they've built their models, they really often don't think about how do they get those scores out to users. When they do scoring, about 90% of the time that scoring is done in batch. You give the data science team a bunch of records, they'll score it, and they'll return those records with a new column or a new table that has scores for each of the elements in that report. Well, MicroStrategy gives a few more options because we don't want you to just stop with that in-batch process. We want to be able to make sure you can deliver those results out to business users. Now, there's a couple ways we can help with that. One is that we do support PMML, so you can deploy models directly from some of these tools that support PMML to MicroStrategy. We also have the ability to persist models using R or Python to serialize models out and unserialize those models back for scoring on the fly in the MicroStrategy environment. And of course, we have Mysterio that allows us to pull data from MicroStrategy and push results back. Now, again, as I mentioned, I like maximum information density charts. Let me simplify this a little bit and just focus on the different flows that you have here, depending on whether you're a citizen data scientist or a full-fledged data scientist. MicroStrategy has workflows that will allow you to deliver these results out to your business users. And let's go back to the time spent doing things. If you think about this a little bit more, if I actually rejiggered the chart above to match what's going on with our survey data, you'll see that the data scientists should be spending a lot more of their time doing data science. But instead, we have a lot of data engineering that needs to be done. In most organizations, especially large organizations, hopefully the data scientist is shielded a bit from doing that data engineering because data modeling can be as difficult as data mining. In fact, you may need a data analyst to help with things, and the data scientists may have a team that they work with, including a software engineering for writing code, maybe a statistician for validating results. And in fact, you have those BI users that also are going to give you feedback on your results. In fact, they may be the ones that become your citizen data scientists. And so you have a lot of roles available in the organization that need to be, played here for your best results in delivering data out to your users. And so I'd like to think of data science as a team sport, which is one reason why I think this community of practice that we pulled together here is such a key thing, because we can pull together a lot of different roles in the organization. I realize that I'm getting at the top of the hour here. I do have a few more demos that I want to go through. We did a few things on average length of stay. In the few minutes that I have left, I do want to talk about how we can do some things like forecasting reimbursements. This is another healthcare example, and I do have some videos here that show how we took data from a number of different sources in the environment and came up with some good deep forecasts. These are a bunch of one-minute videos that I don't have time to go into, but they are here as if you want to do this demonstration that talk about a little bit about how we do things like champion challenger model selection, as well as doing some other cases as well. One last thing is I want to show a third use case of making deep learning explainable. MicroStrategy has a partner, business intelligence analysts. The team at BIA has come up with not just predicting things, and in fact this is a healthcare use case of will a certain patient be readmitted within 30 days. That can actually save an organization a lot of money if you can avoid a readmit. While most tools these days can return a probability, like this individual Lucy has a 97% chance of being readmitted, well, without the BIA solution, you only have some basic information. The BIA solution can not only take that probability, but explain why that probability is taking place. In fact, it shows you all the factors specific to this individual, why their score was so high. And imagine you're a discharged nurse in an organization. Lucy's about to leave your clinic that day. One of the reasons, you'll see that she has a high probability of being readmitted. Well, why is that probability so high? And one of the things you might notice is that a certain prescription wasn't prescribed during this encounter. Perhaps Lucy has diabetes, and there's certain medication that's prescribed for a patient on discharge that hasn't been described here. And so the discharge nurse can go now and address this issue with the primary care physician. This could be an oversight, or it could be there was a drug interaction and something else was done. But at least the nurse can take this information and do something with it, so they can actually do something hopefully to reduce the chance that Lucille gets readmitted within 30 days and save the organization a bunch of money. And so hopefully we've shown you a few things. One last thing I'll leave you with is that as MicroStrategy users, you already have the tools you need. Data science today isn't a technology problem. It really is a people problem, because the technology is available. The tools are readily available. And so you need to find or train good people. Some best practices include collaboration between the business and the data science teams, as well as information technology. It's an iterative process, so you want to be able to iterate fast and iterate frequently. The best practice is also to make sure you validate models against data not used in training. and also to be patient because if it was easy, everyone would be doing it. Thank you, and that concludes the presentation. I'm sorry I ran long about 10 minutes, but I appreciate everybody sitting through that presentation. Hopefully it's a good positioning of MicroStrategy for data science. Are there any questions or comments?
All right. If there's no questions or comments, obviously we can connect over email or in the Slack channel if you decide you would like one. We'll be sharing both the video of today's presentation as well as the presentation materials on Slack. So thank you everyone for attending. I know we're a little bit over time here, and we look forward to seeing you again in a couple of weeks. Again, last thing, if you do have ideas of things that you'd like to share with the group, please reach out and we'll get you on the agenda. Thanks so much, everyone.
Thank you, Derek. Thanks, everybody. Have a great day.
Thank you. Bye.